Use the derivative formula. F prime of a equals limit as h goes to 0 of f of a plus h minus f of a divided by h to find the derivative of f of x equals sine x, where a equals 2 pi over 6. The first thing to do is write down the derivative formula for the a value of pi over 6. F prime of pi over 6 equals the limit as h goes to 0 of f of pi over 6 plus h minus f of pi over 6, all divided by h. The next thing to do is to evaluate f of pi over 6 plus h and f of pi over 6. F of pi over 6 plus h means to take f of x, sine x, and replace every x with the quantity pi over 6 plus h in parentheses. Sine of pi over 6 plus h minus f of pi over 6 means to plug in a pi over 6 for every x in f of x, so that'll give us sine of pi over 6. All of this is over h. We have the 0 over 0 indeterminate form, and we will continue to have that until we can turn this into the identity, because we have trig functions and the power function h in the denominator for the variable h that's going to 0. We're going to make use of the limit as h goes to 0, sine of h over h goes to 1 identity. In order to get that identity to happen, we're going to need to expand the sine sum of pi over 6 plus h using the sum identity for sine. So f prime of pi over 6 equals limit as h goes to 0. The sum identity for sine is the sine of the first times the cosine of the second plus the sine of the second and the cosine of the first. And then we have this minus sine of pi over 6. And all of this is divided by h. We can evaluate sine of pi over 6 and cosine of pi over 6 to simplify our work here. The sine of pi over 6 is a 1/2, so we have a 1/2 cosine h. The cosine of pi over 6 is root 3 over 2, so we have a plus root 3 over 2 sine of h. And then the sine of pi over 6 once again is a 1/2, so we have a minus 1/2. And all of this is divided by h. Limit as h goes to 0. I'm going to pair off the 1/2 cosine h and the negative 1/2. Into one expression. This is all over h. And then the root 3 over 2 sine h, it's also over h. I'm separating these fractions because the second fraction already has the identity of sine of h over h. The first one does not just yet, and we have to do a little work with that one to make it have the identity happen. That first one, we have a 1/2 that can factor out, so it'll be a 1/2 times the cosine of h minus 1, all over the h. That one does not have the identity of sine of h over h just yet, but what it does have in the numerator is a trig combination, a cosine with a combined with another term. It's got cosine of h minus 1. We have a trig conjugate we can multiply by, which will be the opposite sign between the two terms. We're going to put it over itself, a form of 1. And we actually are going to FOIL out that numerator. We have this other term, which is going to be root 3 over 2 times the sine of h over h, which is perfect for the identity, so I'm not going to do anything else with that right now. So we have limit as h goes to 0 of 1/2 times expanding by FOILing the trig conjugates. First, cosine squared of h, outside plus cosine of h, inside negative cosine of h. Those will cancel, being equal value opposite sign. And then last, negative 1 times a positive 1 is a negative 1. Let's cancel these terms out. And then in the denominator, we will not distribute. Keep it factored always. And we have this other term that we will leave exactly the way it is. Now, what we have in the numerator of the first fraction is a Pythagorean trig identity. Sine squared h plus cosine squared h equals to 1. Rearranging this by subtracting the 1 to the left and the sine squared to the right shows us what we can replace sine squared of h minus 1 with. We can replace it with negative sine squared of h. So we have limit as h goes to 0 of 1/2 times negative sine squared of h all over h and cosine of h plus 1. And we have the other fraction, root 3 over 2 sine of h over h. So this is limit as h goes to 0 of, what we have to do with this first expression is isolate the signs, because we need to turn them into the identity as well. I'm going to have the negative just sit with the 1/2. They're multiplying each other, so I can move the negative out front like so. I'm going to isolate, they're still multiplying, sine squared h. Now what we can do with it is write it, since it's sine squared h, we can say sine h and then quantity squared. But I'm going to isolate it so I can put in by phase matching. I'm going to put an h in the denominator. Now it's quantity squared, so it's an h squared. I'm going to compensate by putting 1 in the numerator of the other part of the fraction. So now I have the perfect form for the identity that will limit to 1 in the parentheses there. One of the h's can cancel from the first fraction, so let's cancel that out. And then we have plus root 3 over 2 sine h over h. Once we've done all of that work, those sine h over h's will limit to a 1, and we should be able to plug a 0 into any remaining h's. I have a negative 1/2 h over the cosine of h plus 1, and I have a plus root 3 over 2. Plugging a 0 into the remaining h's will give us a negative 1/2 times 0 over a cosine of 0 plus 1 for that first fraction, and then we have plus root 3 over 2. Negative 1/2 times 0 is 0. The cosine of 0 is 1. Zero divided by any non-zero number is a 0, so we just have 0 plus root 3 over 2, which is going to come out to root 3 over 2. That represents f prime of pi over 6, which is the derivative of f of x with a pi over 6 then plugged in for x.